However, we can just use the SPUs to decrypt the code. So Sony's idea is, yeah, they can't see our code, so they can't find bugs in there. Well, as soon as we have PowerPC access, we can just ask the SPU to nicely decrypt stuff for us, and it will do so. It does not do any checks on what actually asks you to decrypt things. So with this, we just use Asbestos and this NetRPC thing, write some Python scripts on the PC, and use it to like decrypt application selves or level 2, or like just about decrypt just about everything now by just asking it to do it. So we don't even need to know how it works. We just have to ask it to do it for us. But, so yeah, the obfuscation is useless. But we but we still want keys. But let's first take a look at our table again, what we did now. So we have the security code processor there. It's pointless. So and let's go one step back to the chain of trust I showed at the beginning. So here we have it again, and I'm not going to explain and on the left you just see what is run in chronological order, and on the right you see the usage. And there are two things there which they can't update. It's bootloader and metloader. So bootloader is the very first thing that runs, and it's just the very first thing that runs, and metaloader is used to load isolated SPU binaries, so they can't update that because it's encrypted with a console-specific key. And yeah, the rest can update all the other things, and they don't want us to downgrade. So they added some revocation. You get the revocation list, they are stored on the NOR or NAND flash as well, and the loaders verify if you try to load some binary, is this on a revocation list, and if it is, it will just refuse to boot. So the stuff at the top, it cannot be revoked because the previous loaders do not support any kind of revocation lists, so Sony did something else there. So first, it reads bootloader, LV0 metloader, LV1 loader, and LV1 from the NAND, or from the NOR on your PS3s, and just runs them. And then once LV1 runs, it loads all that stuff again to verify it. So you can just remove the NOR, plug in a mod chip in there, so when it's read first, you supply your downgraded version. Then when the PS3 reads it for the second time, you supply the real version it's supposed to run, and it will just run because it thinks yeah, I am running the current version, so I can just continue to boot. And this allows us to downgrade everything, because we can just downgrade the revocation list as well, so the revocation is useless. It's just some kind of specification thing. There's no revocation there. So as soon as we break one loader, we break it forever. We can forever own all PS3s out there. So we need to do that. So here we have the local storage again. It's an isolated mode, so you can't access the red stuff. Only the SPU itself can do that. But you can access the green stuff, and you need to supply a revocation list. So this list is, of course, signed and encrypted, so they have to copy it to the protected part, because they don't want you. If they would decrypt it in place and check the signature in place, you could just wait for it to do that, and then at the right time write some PowerPC code to modify it. So they really have to copy it. And here's how they do that. So what's wrong here? The problem is that we have the destination buffer lies before LV2 loader code. The SOAR buffer, so we control the source and we control the length of the source. So what if we just write some really, really huge value there? Well, we overwrite LV2 loader code and run code in isolated SPU mode. Then we can just go ahead and dump their keys. Just write something to push them over to the PowerPC, and then, yeah. Then we can actually reverse the whole loader and we get some keys there. So what are the implications of this? So it's only a bug in one isolated loader. However, if we put such a modified revocation list onto the NOR flash, the hypervisor will just load it. It does not care about the size, and that code actually works, and it will just supply a really huge revocation list to LV2 loader. Then we patch LV2 loader to ignore signatures, and well, we get our code running at boot time without any kind of dongles or stuff. And this breaks the chain of trust pretty early. So as you can see there, this is fail. But we promised epic fail, so we'll have to look further. So let's go back to the table. Well, the chain of trust is broken. And back to the selves. We now like how just about everything works here, except for the signature part. So how do they do that? How does the signature thing work? So this is ECDSA, and it's some crazy math stuff that guy over there is going to explain now.
Hi. Okay, so the thing we're trying to do is figure out the private key they use to put signature on all the files. You normally cannot do that, of course. That's why it's a good crypto system. In ECDSA, there's a lot of parameters that are public, that P, A, B, G, N, Q, E, R, S, whatever. But there are two things that are private in a single signature. That's K, the private key, which we want to have, and it's M, which is supposed to be a random number. Okay, next slide. Okay, so how does someone who signs something calculate the numbers R and S, which are the signature? Well, R is done by scalar multiplication of base point of the elliptic curve, blah, 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 difficult stuff. It's the difficult problem that that's the base of the security of all elliptic curve crypto. But S is just calculated as normal numbers. Well, so that first equation we cannot solve. No one in the world can solve it, so let's just ignore it. But the second equation, it's got two unknowns in it now, K and M. So we cannot solve for it either. But M is supposed to be a random number. And for some reason, Sony uses the same random number all the time. So there at the top are the two equations again, but twice now, like we have two separate signatures. We're going to ignore that top one again because it's difficult, right? But now at the equation for S1 and S2, we still have only two unknowns because it's the same M. It's supposed to be a different M every time. Then we've got three unknowns, only two equations. No way to solve it. But now we've got only two unknowns. So it's trivial to just solve for M by just you take the two formulas, subtract whatever, just a bit of formula manipulation. And then you solve M, and then you've got M, and you just fill it in, and then you solve for K. So we've got a private key without even having to know most of the curve parameters and anything.
So we actually used ECDSA in the homebrew channel's network update function so that someone can't own your Wii through a man-in-the-middle attack or something. So this is how we do it, right? We do the easy math. You can see the M times EG, blah, 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 blah stuff there. And for M, we read cryptographically secure random numbers from dev-random on Linux. You know, that's what you're supposed to do, and what Sony does is, well... And of course, as Sekar explained, if you use the same M, you can calculate K once you have two signatures. And if you have K, well, that's a private key. And with a private key, you can sign things. So these signatures are every bit as valid as Sony's official signatures. They are indistinguishable. And we can get keys for LV2, we can get keys for LV1, we can get keys for revocation lists, we can get keys for hypervisor configuration files, which is interesting, and for packages and a whole bunch of stuff. So
we actually don't have keys for level 1 because we can't run that loader because it does weird hardware stuff, so we still have to figure that out.
Yeah, sorry. So in fact, you can get the keys if you have the plain text for all the loaders. But right now, Sony's security for the few loaders that haven't been dumped yet hinges on just the AES stuff that we don't have and the per console key. But everything that you need to get these keys is inside a PS3. You just have to get to it. So back to the table here. Well, they botched the public key crypto, so that's a big fail. And we're left with user kernel mode and on-die boot ROM, which are not exactly high-tech security features. So pretty much botched the entire thing.
So thanks, Sony.
All right. Coming soon.
Looks like we might have a little bit of time for questions, for Q&A.
We're actually going to try to do a demo of this, and we were going to do it now, but as usual, demos are late or don't work. In fact, we have video issues the same way we had video issues with the BootMe demo 2 years ago. So we're going to try to fix that, and we're trying to schedule a lightning talk tomorrow to get that presented.
So if you have any questions, we have 2 microphones on the left and on the right. Please line up. And if you're afraid of asking questions in public, the people are down at the Hack Center.
I got a question. Do you know where the PS jailbreak came from?
Not a clue. Seriously, not a clue. We can guess, but we don't have any proof of absolutely anything.
We think it's somewhere from the southern hemisphere.
And right now, I noticed that the not only the exploit, but the USB stack exploit, but also the payload has been completely reverse engineered. So there's source code available right now for everything.
Yeah, well, right now, Asbestos is public, has been for a while. It contains an implementation of the USB exploit that runs on TI OMAP processors. There are a whole bunch of clones for other chips. And of course, there's also a reverse engineered payload for that if you want to replicate the original PS jailbreak functionality instead of running Linux. That's out there right now. Our stuff, we did some pretty terrible hacks to make it work for the demo, hopefully tomorrow. So we need to clean things up and make it saner. But I mean, I expect that in the next month or something like that, we'll release clean tools for the stuff that we did here.
Thank you.
Okay, question from the IRC. Now that you can sign your own code, why can't you create a Blu-ray software payload?
Could you repeat that?
Someone asked, now that you can sign your own code, why can't you create a Blu-ray software payload?
So we actually don't have the key to sign games because that's AppLoader, and they changed those keys several times. Actually, no, they didn't change those keys, but we don't have it. Why don't we have it? Because we don't have an exploit in AppLoader, sorry. So yeah, you need the plain text of the loader to get the public key, and once you have the public key, then that. So we can't sign games, and also we don't really care about games because we care about low-level access.
It's probably possible eventually, but we're not planning on working on it.
Yeah.
So any more questions? No? So if you leave the room, please go to the right, pick all the trash which is around you, and everything that's valuable, please put to the lost and found. Thank you.